So, welcome to our hands-on on SQL. SQL is a query language with which we can access databases, relational databases. For that, we usually have to install a database management system, including the language, the SQL tool, with which we access the database, as well as the database itself. Since we do not want to do that, just to get a bit of exercise, we are using one of the tools I provide you with in the slides, which are then running in the cloud. So currently, this one is running in my browser, and it's a tool with which we can access an already installed database management system and a database running MySQL in the version 5.7. On the left side, you see Schema SQL. On the right side, you see Query SQL. So the right side is the one where we actually will use the most time, with which we can do queries to access our relational database tables and access rows and columns within those tables. However, even though the database is installed, it's currently empty, so no tables are created and in the database. So we first of all have to create those. Therefore, this Schema SQL, the left part of this whole website, can be used. And we would now have to write SQL schema queries, so to say, to create tables, insert data into tables, and so forth. However, since we do not like to do that because that's too complicated, because most of the time in our real business life we would anyways only access databases and the IT guys would implement those databases, we will concentrate on accessing with Query SQL. And we will use the tool text to DDL. You can see in the bottom left here, which you can click, with which we then can just insert tables into the system based on text. And I provided you with those text prompts you need. You can find them in Teams and can download them. Those are actually 3 CSV files, so comma separated files you can download, and I already did for you do that. And I downloaded them in my folder SQL Basics. That's Persons.csv, Products.csv, and Transactions.csv. However, CSV files are standardly opened with Excel because they often hold data. We, however, want to just get the text of those files. So we do not open that with a double click or a long press, whatever a Mac is using, but we right click on it and use open with, and then use the editor or any tool similar to that and open that. And then once we're in the editor, we then should be able to open Persons CSV, Products, and Transactions CSV based on right-clicking it, open with, then editor. I start with Persons CSV, and you can see there are data. There's data with a semicolon separated, so comma separated file. And we just mark all of that, copy that, and paste that into the formatted text file and just give it a name. Since this is the Persons CSV file, we just call it Persons and click Preview DDL. And then we can see it interpreted our comma separated file into an SQL prompt where it creates the table we need to and inserts the values in rows into that. So there are 6 files here. And then we click Append to Schema. And then we do it again for our next file, Products.csv, which we then right-click open as a text, copy that, paste that into that, and call that Products, and append that to Schema as well, and do it one final third time, where we use Transactions, and copy that, paste that into here, call that Transactions, preview the DDL, append to Schema, and now we have 3 tables, and if we click Run, the Schema SQL is executed, and we have now 3 tables in our database. So that we are able to access now. For example, let's say we want to access the table Persons. So we want to select, now we have to declare, as we learned in the lecture, which columns. If we want to just select the full table, all columns, we can just type star. Then we want to select everything. From which table we want to look at Persons. Then we have a semicolon to end the query. If we run that, we then can see, oh, person is opened. It has the column person ID, name, city, street, number, gender, and age. And within that, we have 6 rows. For example, Tom from Karlsruhe, Peter from Reutlingen, or Catherine from Stuttgart, and so forth. Cool. We can do the same thing if we want to access maybe, let's say, not all the columns, but only one column, only city. We can just change that to city, and then we would only get the city column, but still all rows, as you can see. All right, but what if let's just execute it again with star so we see the full table. That makes it easier. But now let's say we don't want to access the full table here, okay? We maybe only want to see certain rows. For example, only persons who met a certain condition, like, for example, persons who we maybe only want to know in which cities persons live. Let's start with like that. Maybe we only want to know in which cities persons live. All right, so we go to city and run that. Then we can see, all right, there are cities Karlsruhe, Reutlingen, Stuttgart, Mannheim, Reutlingen again, Stuttgart again. So we have duplicates in there. Well, if we have the question, in which cities do our customers, for example, live? I don't want to know that Reutlingen is there more often. My question was, just give me the city, so no duplicates. So we can get rid of duplicates by only getting distinct values, and we just write distinct in front of the city in the selection, and we should not have duplicates. Well, see, now it's only Karlsruhe, Reutlingen, Stuttgart, Mannheim each once, and not duplicates. All right, but now coming back now. Just select the full table again so we can see it. Now let's say we only want to get certain customers, certain persons who met a certain condition. Like, for example, we only want to know our customers who live in Reutlingen. All right. So we want to select all columns because our question didn't specify what we want to know from them. We just want to know all of them. Persons is still correct because we want to know them from persons, but now only where a certain condition is met. So where the following applies. And in that case, that they live in Reutlingen, so the city must be equal to Reutlingen. And then we run that. And you can see only the customers who live in Reutlingen, so Emma and Peter, are now given back from our query. Cool. So these conditions work quite well. But what we already learned is that we can combine them as well, right? So we could basically where conditions, as this one, we can combine, we can link them together with and or not. The same is true for Python in their if statements, right? It's a logical and or not. So if this is true and that is true. So the logical and means both conditions are met. Only if both conditions are met, the result will be returned. So only if, for example, I only want to know customers who live in Reutlingen and live in Nebenstraße, then an and would be only giving Peter back. If I would use an or, it would be enough if either one of the results is true. So I say, give me all customers back who live in the city Reutlingen or live in Nebenstraße. Both would be returned because Emma still lives in Reutlingen, so the condition is met as true that she at least lives in Reutlingen because an or statement was enough. All right? Let's just get rid of that. And wait. And if I run that and I would say now, okay, give me where people live in Hauptstraße or Schillerstraße, for example, where street equals Schillerstraße or street equals what did I say? Let's say just Hauptstraße. then this one should be returned and this one should be returned, right? Because it's an or. If I type in and, none of them should be true because nobody lives in 2 streets at the same time. All right? So logical stuff here. All right. So we basically have those conditions, and we can use them to combine where's 2 more than 1. And with that information and what I just showed you, I now want you to try to solve the following 4 questions. All right, those are exercises you now work on. You hit then pause and try to answer those 4 exercises, and I will show you the solution of them one after another after the pause. So hit pause, try to solve those 4 exercises on your own, and the solution will be right the next thing we will have. So the first question was, list all persons who are older than 25 years old. So basically we select all persons, everything from persons, and we just have to meet the condition where age needs to be larger than 25. And as you can see, those are those 3 people. This is Catherine, Marie, and Tom, who are older than 25 years. Next question was, please enter all male persons from Reutlingen. So let's just go into that. So we want to select everything again from persons, where now 2 conditions are met. The first condition is they need to be from Reutlingen, and the second, they need to be in gender, which we have here, should be male. So both need to be met at the same time, because if not, we would have all persons in Reutlingen all male, but not all male out of Reutlingen, or only male out of Reutlingen. So this should now work, and it's only Peter. All right. Next question. The question was that we should enter all products from warehouse 2 and 3. So this isn't that hard as well. We just now have to go, let's go first of all to a different table. So we just start selecting all from products, and we can see if we select all from products, we get to product ID, product name, and so forth, and then we have warehouse as a column, and it could be 1, 2, and 3 in our case. So we want to select those who warehouse is either equal to or equal 3, because every product which is in either one of them, right? So because no thing can be at the 2 warehouses at the same time. So what we want is it's either in warehouse 2 or it's in warehouse 3 at the same time. And if we run that code, it's those 2, which is a screen and a keyboard. All right. And the last question was that we want to have name and city. So we select name and city from of all persons. So from persons, from Reutlingen, so city needs to be Reutlingen, and they need to be younger than 20 years, so younger age. And this is only Peter. Is Peter actually younger than 20? Let's check that by selecting star from persons, just to make sure our thing worked. Peter was 18, so that was actually correct. All right. Cool. I hope you did manage to get all answers, but we're not done yet. So let's hop into grouping. So there are certain things which are implemented in SQL we can use, like a group by, an order by, and an count. All right. So an order by helps us to sort our data. So we can say we want to sort stuff in an ascending or descending order. So from the smallest to largest value ascending, or from the largest to smallest value descending order. We can use functions like count, where we then basically say, okay, how many entries do you see? Count them together. So how many customers do we have from a certain city, for example? Therefore, we can use functions which are implemented like count, and group by helps us to group groups together. So we could basically group all customers from one city, then count them and group them from the next city and count them. So we could say like we have that many customers in Karlsruhe, that many customers in Reutlingen, and so forth. This is the magic of pre-installed, you could name it, functions or which are already within SQL. And we want to start now with ascending and descending order, so just sort stuff. So let's start with selecting everything from, let's say, persons. And this is the usual standard order. But now we want to order them, all right? So let's say we want to order them by their name. For alphabetical order, so from A to Z, so that is then ascending order. So now if we look at the name, Tom shouldn't be on top because T comes quite late in the alphabet. Emma might be quite in lead. Let's look at it. Emma, Catherine, Marie, Max, Peter, and Tom. So this is now ordered. All right, ordering works. Now we look at easy functions. Okay, let's do that. So we can also use simple functions such as count, an average, and a sum. So let's look at how many products are in the warehouse. So we want to count how many products are in the warehouse. We could basically say how much they cost on average or how much they cost in total with a sum. Those are the predefined functions which we can use to make our lives easier. But let's just implement a count as an example to get used to that. So what do we want to do? So we first of all want to select star from warehouse and from products to get a feeling for what we can achieve here. So this is how the table usually looks like. And now we want to count how many products are in a warehouse. So let's say in warehouse 1. So we probably want to only select warehouse. This column equals 1, right? Maybe we only want to do this. So let's do that. So now these are the 2 entries, but this is not our question. Now we have the 2 lines. We want to count how many there are. So instead of having that, we want to have the count function. And what do we now count? We basically count how many items there are in our result. So product name, price, or even warehouse. So if we count warehouse, it should count how many entries there are within, so lines basically within what we do here. So let's take warehouse, then we should get count warehouse 2. So because there are 2. Cool, we managed to do it. Now, one last thing which we can do. While we now have a result count warehouse, and we do know that there are 2 in the warehouse, some might find that not that easy to read. You probably at the end of this lecture are able to read it because you do know what the count function does. However, some not familiar with SQL might not be able to read the result of that query or that prompt. So why don't we give that a more easy to read name? Because we can rename whatever the label here should be by using the as function. By using as, we can say how that should be called, because that result should be represented as and let's just say we want to call it as Anzahl. Oh, that's German. Amount of products in warehouse 1. And if we run it again, that's the amount of products in warehouse 1 is 2. Now this is a simple database with a simple table, and there are not that many products there, but in a larger database, that might be fruitful information because you're not able to count like 225 rows or whatever. and that might help you. So having done this, we are getting to a new exercise you should work on, and please try to use please try to answer the following question. You should enter the number of customers per city and sort your results from Z to A. A small hint, you will need the group by. This is quite a challenging question because we haven't used the group by in the video so far. However, we did do that in the lecture, so you should be able to use it. If not, just look at the solution, which will be right after that. So hit pause now, then the solution will be shown. All right, so let's start that we want to look at persons, because in persons, we do know our customers and in which city they live in. So this is basically our entry table. And in that entry table, we have the first thing we have to look out for. If we want to count how many people are in the city living, all right, we would basically say Karlsruhe is one customer, Reutlingen would be 2 customers, Stuttgart would be 2 customers, Mannheim would be 1 customer. The problem is, if I want to show that, it somehow, we want to probably show the city and then how many people are in the city. So we want to give back city, so basically that one, and then the number of how many people are living here. So it's kind of hard because Karlsruhe then should only be displayed once. Reutlingen, which is twice in the database, should only be displayed once, but with a 2 right next to it as count city. So we have 2 lines which need to be 1 line. That's why we need a group by, and we want to group the results together based on a certain value, and this is city. So we group by Reutlingen in 1 line, and then this line is shown, and the number of how often it is in the database is shown right next to it. And you can see Karlsruhe and so forth is then displayed. However, to make sure it's ordered correctly, because we should do that, order by city descending. And what we as well could do is as amount customers in city. So it's displayed nicer. So the amount customers in city Stuttgart is 2, the amount customers in city Reutlingen is 2, and so forth. And now we have it from the largest to the smallest number, which is nice as well. All right. So from Z to A, that's what we should do. And this worked out. Cool. Coming to our next part of the video. This is basically joining tables. Joining tables is important because with joins, we can link together 2 separate tables in our database. In our database are currently 3 tables. It's persons, products, and transactions. And we can somehow link them together, joined together. Therefore, we can use keys and foreign keys to do so. So let's just look at our tables. If we look at persons, each table has to have an identification, a key, which identifies which row we're currently talking about. And person ID, so it needs to be unique and cannot be repeated. While, for example, Reutlingen can be there twice, we need to somehow know, okay, which customer from... So which Reutlingen we're talking about? The Reutlingen from Peter or the Reutlingen from Emma? So there needs to be a unique identifier to know it's this or that. And this is our identifier, person ID. And this is unique. You see 1, 2, 3, 4, 5, 6. It never repeats. So the next one must be 7 or any other number which we didn't use yet. All right? Unique. So this is the key. It locks the line we're looking at and opens it. It identifies it uniquely. And we have a similar thing probably in then products. All right, in products we have product ID. Cool. Why? Because product name, price, and warehouse aren't unique. And what about transactions? Oh, we have a transaction ID, which is unique as well. However, we have two new columns, person ID and product ID. Those were the identifiers of the other columns because these are foreign keys. I can now see that in the first transaction, so the first sell we did on our web shop or whatever this is basically done by the person, which can be uniquely identified by its ID1, and he or she bought the product, which can be uniquely identified by the ID1. So with that key, which is here, which is the foreign key for product, we can link that transaction, if we want to that product and that person ID. So transaction 1 was done by the person with ID1, by Tom, and Tom bought product 1, which was a laptop, at the date uh, 20th of June in 2020. All right, so this is how the key and foreign key works. And now we can join them together using that. Let's just say we want to select everything from persons. Let's start here. And then we want to know, we want to combine the persons table, which is that one, with that transaction table you can see. So we will combine that with the other table you just saw. So we use the a join, which we call just join here, and just tell with which table we want to join that. This, however, now doesn't work. Oh, it actually works. It does it on its own. Oh, that's fun. It shouldn't work, by the way, because we now need to tell the join on what to join. So we do that for the sake of completeness, even though this installation or this current version of MySQL already does it for us. But we now need to tell so you don't see the solution yet. We now need to tell on what to join. So persons need to be combined with transactions based on a certain identifier. And we do that, we tell the system usually what that is. And we do that by telling basically now that we want to join on person ID, but the person ID from persons. So from the table persons, we want to use the column as an identifier, which is called person ID, as here, and want to join that in the case or on the case that it's equal to transactions, and there the column person ID. And now this join should work, and we can see that Tom, Karlsruhe, Hauptstraße did buy in the first transaction something with a product ID 1 at this date. Peter in the second transaction, and so forth. So we combine that. So for example, the fifth transaction was done by Marie, while the fourth transaction was done again by Tom. So Tom bought 2 products already. Marie bought 2 products, product 3 and 5, for example. So we can join that. So having that knowledge, we are now getting to our final exercise you are able to perform now. The exercise is, please list all the products that Tom and Max have bought. Tom and Max, okay? This is Max, this is Tom, including who bought them. So we want to know, is it Tom or Max who bought which of the products? Which product they bought. So product ID isn't enough, we want to have the name. And when the date it was. And then we sort that in descending order based on the transaction ID. Hit pause, try to solve it on your own. I show you the solution in a second. All right, let's start. First of all, the date is in transactions. The name of the person is in persons, and the product name is in products. So we need to select something from the first table, join it with the second table based on the foreign key example. So persons person ID needs to be joined with transactions person ID. And then once we join those two tables together, we need to join them with the third table, products. On transactions has the product ID and products product ID. Now we joined all three tables together. Then certain conditions need to be met. We want to only see the transactions of Tom and Max. So only where the person name is either Tom or it is Max. Then we want to order that descending based on transaction ID. So we order that based on the transactions ID in ascending order, and the transaction ID can be found in transactions. Last but not least, what do we want as an answer? We want to have the transaction ID. We want to know which transaction it was, so that's found in transactions, point transaction ID. Then we want to have the name of the person, that's explicitly including who bought them in the question. So the name from persons need to be displayed. That's our second column down here. Then our third column is then which product, so the product name from products product name, and when from transactions the date. And once we execute that, we see that D3 transactions were made, 2 products were bought by Tom, 1 by Max, and you can see the transactions down here. All right, that was it. I hope it was okay for you and you could solve the questions on your own. Have a nice day. See you next time.